So I'm going to be discussing buddy skills in Monster Hunter Rise. Not what skills or moves you want, or what's optimal, there's already a ton of opinions out there on that, but how the underlying system of rolling for skills actually works, and how this is likely very different from what you would expect, or what many sources say. Alright, so when I say buddies, I mean Palicos and Palamutes, or felines and canines with a Y. For this video, I'll just be referring to them as cats and dogs, and it should be pretty obvious which one is which. Also, when I mention buddies' skills, I'm referring to things such as attack up S or status attack up, and the like, not cat-specific moves like healing bubble. Here's a brief overview of the video, and there should be timestamps too. So firstly, dog skills and weighted probabilities per skill, then cat moves, classes, and their related weighting. After that, we'll discuss how cat skills work in relation to their specialization, or their class. And after that, we'll get into actually showing how we know this, as well as why we think that the probabilities and systems work as we think they do. This is where some math and statistics comes into play, so you're good skipping this part if you're willing to just trust me. Then we'll sum up. I'll tell you what all this means simply, and if you've been disheartened by knowing that your chances are much lower than expected of getting these skills and moves you want, then I'll tell you how to skip all of this through either mods or similar utilities. Okay, so let's get started with dog skills. I'll go off notes for this part just in case I get something wrong. There are 23 skills in total that a buddy can have, as seen on the screen here. Each buddy will have 8 skill slots, and every one of these skill slots must be filled by a skill. You can't have a buddy with just 2 skills, for example, at least not normally. If you had an equal chance to roll each skill here, as most sources do think, then the math for determining your skill chance is pretty simple. I shouldn't have to explain it. Pretty much, you have a pretty solid chance of getting the skill that you want in one of your slots. However, this isn't actually the case. This is the new information. Each of these 23 skills has its own distinct weighting, its own chance to be rolled, and I'll put up a table of these here. I won't explain how these were found out or how we've confirmed this quite yet. That will be in the more technical part. But this table should explain why health up almost always shows up, for example, and why other skills such as Artful Dodge are a bit more difficult to get. I'll leave it on the screen. I'll leave the table on the screen for a bit if you want to look through it, or just in case, for example, you need to pause or you're coming from a timestamp. So that is dogs covered. You might think that cats work in the same way, drawing skills off the same weighted table, but unfortunately that's not true. Cats are quite a bit more complex. Take a look at this. This is a single skill for a dog, with the weighting here, and this is one for a cat. Notice the difference in length. Clearly there is something else going on. But before we get into skills, it's best to cover their moves first, and their classes. You'll see why in a second. So, each cat has a specific class. For example, they are a healer or they are a gatherer. And this actually determines the probability of them rolling specific moves. The first and last move for each class are set in stone, or at least the game treats them to have a probability of 100 of being rolled. So we're only really working with 3 slots here, each with 5 potential options, each option linked to a specific class. Here's what I'm talking about. This figure here. As you can see, the move the move linked to each specific class has a weight of 32, almost double the other 4 skills, which have a weight of 17. For example, a fight cat is far more likely, almost double as likely, to end up with a power drum in its second slot than it is to get one of the other ones. This is actually the real surprise to me, that this effect isn't more common knowledge, as it's definitely a strong enough factor to be noticeable. I've rolled through many cats myself looking for the perfect one, and I've somehow never made this connection until digging deeper. So yeah, once again I'll leave this figure up again if you want to take a look. Okay, so back to it. Why did I cover classes and moves first? Well, it turns out that the skill weighting for cats is actually linked to their class. There are 5 separate skill weighting tables, one for each class, and it turns out they match up with their intended role pretty well. For example, fight cats are more likely to get offensive skills, and so on. I put a table on the screen here, once again, for you to look at. This one is a little bit larger than the others. Let's see here. For example, attack up large is far more common on fight cats than it is on a healing one, and the opposite is true for, let's say, medic's touch. What does this all mean? Well, it definitely makes some combinations a bit more difficult to achieve, a bit more rare, including some pretty common ones, or ones that you would want. For example, if you want a fight cat that has Go Fight Win, Anti-Monster Mine, and Shock Tripper as moves, and as skills Status Attack Up and Artful Dodger, then you will need some luck. This specific combination is a bit more common if you had an assist or support cat, but who would ever want one of those? Once again, I'll leave the figure here for a bit. Okay, so I've told you a bit of information that you might not have known, but how do you know that all of this is accurate? Well, this section goes a little bit more in-depth and has a guest appearance from a friend who is going to explain a little bit of probability. Alright, so how do we know that the weightings actually do anything? It could all just be junk data that's not really included in the roll calculation. Well, here we have a dog, or many dogs with only 2 skills. The weights of every other skill have been set to 0. So, that's a good start. We know that the weights actually do something. Alright, so let's see if cats roll differently between their classes. The cats shown here they exist in a world where they only have access to 8 specific skills, except for fight cats, the red ones. They have weight tables that are completely normal. They have access to all 23 skills. As you can see, this is reflected in their skills at the Buddy Merchant, and yep. So there's that. Cat skills are weighted differently depending on their class. Now, the actual difficult one. How do we know that weights work the way that we think they should? With a weight of 5, for example, being worth 5 times a skill with a weight of 1. Yeah, that things are proportionate and that the devs haven't used these values somewhat strangely. Alright, so here's where some actual testing needs to be done. The easiest solution is this one. We can do some experimental stats to compare population results against an expected value. So we create cats with only 9 available skills, and as there's 8 skill slots available, one of these skills needs to be left out. If weighting didn't exist, then the chances of one specific skill being left out is just 1 in 9. There's 9 skills. But if we assign all but our target a weight of 5, and our remaining target a weight of 1, things get interesting. Here I've called a friend to explain how we arrive at our expected value, what we want to test against. This is someone with a bit more probability experience than me, so I will cut to that.
Hey everyone, Santad here. So as Kieran just said, it looks like we have a weighted or non-uniform distribution to figure out the skills for the buddies in Monster Hunter Rise. To figure out what this means exactly though, let's look at the more simple uniform case over here. Basically in this, all of their skills have the equal chance of being pulled. So for a brief bit of probability, basically the chances of an event happening is just the way something could happen divided by every single event that could happen, whether we want it or not. So in the simple case, where we have 2 skills, we have 2 possible slots and we pick one of them. The chances of not getting this skill we want, this gray skill, is just 1. So we have 1 possible way. This doesn't happen, divided by all possible events. Right now there are just 2 possible events. We could either pick the skill we don't want or the skill we do want. So that's just 1 plus 1 or 2. Now, what happens if we add 1 more possible skill? And right now we're saying we have 3 possible skills, 2 slots, and we want 1 of them. Basically, right now the chances of not getting the skill we want is 2 out of 3 for the first skill we choose. So we have 2 possible events that we could get, so that's just 1 plus 1, or 2, divided by 3 possible events in total, so that's 3. Once we get that though, once we figure out that first event, we might knock out one of those events, and then we go to the same situation we were at before, where we have 2 possible skills, one that we want and one we don't want, and that's why I just multiply by the amount we got before, 1 on 2. Now if we add one more skill, one more possible skill, and one more possible slot, we have the exact same pattern forming. We have 3 on 4 chance of not getting the skill we want. And once we do that, we end up in the same situation we were at before, where we have 2 out of 3, and then we end up in the situation where we have 1 out of 2. And basically, we can continue this all the way until the end. At the end, we can just multiply all of these together. So in the end, we end up getting 1 out of 9, or about 11.1%. Now this is the chance of not getting the skill we want, so the chance of getting the skill we want is just the opposite. So it's just 1 minus that, or 88.9% or so. Super easy. Now the weighted case is not that much harder. Basically, instead of having the 50% chance, the 1 out of 2 for the first one, we have 5 on the top, because they are 5 times as likely to get the skill we don't want, so we can just write down 5. And on the bottom, instead of dividing by 2, or 1 plus 1, we divide by 5 plus 1. In other words, right now, we have a 5 out of 6 chance of not getting the skill we want, which makes sense, which matches what we have there. If we add one more skill to it, it's very, very similar. Instead of getting a 2 out of 3, we get a 5 plus 5 on 5 plus 5 plus 1, which is the total amount. So that's just 10 divided by 11. We can do the same thing each time. Essentially, we should have 1, 2, 3, 4, 5, 6, 7, 8 numbers here. 1, 2, 3, 4, 5, 6, 7, and then one last one, times 41. And that is every possible event. We can multiply these together, 59.7%. And the probability of getting the skill we want is just 1 minus that, or 40.3%. Let's write that again, 40.3%. As you can see, in the uniform case, where all of the skills are equally the same, we have an 89% chance of getting the skill we want. When the chance of the skill we want is less likely than all the others, we have a much lower chance at 40.3%. And from that, basically, you can see that when we have a weighted skill, the overall chance is going to be very different to when we have a uniform or non-weighted skill. So this technique only works if the amount of slots are 1 higher than the amount of skills. In cases where this isn't the case, the math becomes a bit more complicated because we have to do this stuff over and over and over again. So it's a lot easier to do on a computer than by hand. I'll go for that in my video on this topic, so if you're interested, see you in that one.
Okay, hopefully that was somewhat enlightening. Ralph is currently in the process of making a calculator for getting exact chances of a specific buddy build. Let's say you want to get 3 specific moves and 2 specific skills. What are the chances of that? So if you're interested, it should be linked. So now that we know this value, we can start just generating cats 7 at a time and writing down how many times our skill showed up. I made our target skills stand out color-wise, for example. There's differences between red and blue, just to make things a little bit easier. As you can see with this batch, our target skill showed up a total of 5 times. And after that, it's back to the arena to be Rajang food, so we can get another 7 cats. I ended up doing this for 105 cats, just so we could get a somewhat decent sample. The skill itself ended up showing up 38 times, which is pretty close to our expected 40-ish%. But of course, we need to run a comparison, so here it is, uncorrected, because we have 105 entries, and yeah, the results show that it's good. Our observed and expected values are the same, and that means our weights work as expected. Of course, this isn't perfect proof. There's a chance that this could have just come about through rare coincidence. For example, if the devs decided to use some especially arcane algorithm to roll for skills and we ended up with the same result, but this is incredibly unlikely, and as our results are support towards the most likely implementation, then it's best for our sanity as well as our time to just accept it. Alright, so let's sum up. The takeaway message is pretty simple. Skills and moves are not weighed equally. Be aware of this and check the tables or a calculator if you want a better idea of your actual chances. Dog skills share a probability with fight cats, and cats are more likely to both get skills and moves that align with their specialization. This is info from within the files itself that we've then verified through observation, so we could be fairly sure that it is accurate. So, the important question, how can you circumvent low chances, especially if you picked a rare combo, or want a cat with a rare combo? Well, you can't really, at least not in the game. Knowing the info itself doesn't really give you the ability to change it, unfortunately, unless someone works out something absolutely brilliant. That is, of course, besides lowering your expectations. But if you watched the proofs section of the video, then you likely saw some interesting things. Well, some cats that had rather odd selections of skills. And I have good information that someone out there will be releasing a tool that lets you specify buddy skills and moves. Perhaps even tomorrow or the day after. So I'll link to that in the description when it is released. Also, I think there is a CE table out there somewhere that can get similar results if that is a path you're willing to take. What else? Of course, I'd appreciate some interaction with the video if you actually made it through. If you want to calculate or find out how to calculate chances of a specific buddy, then view Ralph's video and calculator, which will be linked eventually. And that should be it. Thanks for watching.